3D Printing Homes, The Future of Housing by Gurshan. This is the table of contents. I'll mainly be talking about how 3D printing houses work, its advantages when compared to traditional homemaking methods, the job opportunities it provides, and how you can get started if you are interested in a career path in 3D printing. Firstly, I'll talk a little bit about what 3D printing houses is. Although houses are traditionally built using a variety of materials, pieces, and workers, 3D printing houses is the latest trend in homemaking, as it requires less material and is created almost entirely by 3D printers. It is a far less expensive and less known method of creating homes and is mostly used in creating more affordable homes where they are most needed. Now, I'll be talking about how it works and how the materials and 3D printer used to make it are different from the 3D printers we use at our homes. So, what are the 3D printers used to make these homes like? Well, whereas normal 3D printers are used to create small models using filaments, the 3D printers used to make homes use special concrete and do the task of building the individual parts of homes. As you can see, a few more differences include their dimensions, with the 3D printers used to make homes measuring 4.5 by 1.5 by 1.5 meters, while desktop 3D printers measure, on average, 0.255 by 0.19 by 0.19 meters. Their tolerance levels, with 3D printers used to make homes having an error tolerance as low as 0.15%, their usages, and, most importantly, the materials they use to print. Speaking about the materials they use to print, I'll talk more about it in this slide. As you can see, although normal homes use traditional concrete, 3D printers use proprietary concrete. And as you can see, proprietary concrete is made with pretty much the same materials as traditional concrete, such as cement, coarse aggregates like sand and gravel, water, but also with an additional ingredient which reduces the hardening time. This is a vital component because traditional concrete hardens within the 3D printer's fluid tubes, causing grave damages. Proprietary concrete, on the other hand, hardens slower and allows for the 3D printer to have an easier time creating the home. Now, I'll explain the steps required to make the homes. The first step in 3D printing a house is to design a blueprint in CAD format. This is so that the printer is able to process it. Which brings us to our next step. Step 2 involves the blueprint being sent to the printer for processing after being revised. Then, the printer is taken to the building site and begins printing all the necessary pieces during step 3. Finally, after all the pieces are printed, workers, electricians, and plumbers must work together to make sure the cables are all in the right locations and then to assemble the pieces. Now I'll be talking about its advantages. In this slide, I'm going to be talking about ways that 3D printing is better than traditional housemaking. Firstly, it is very cost-effective. Whereas traditional homes use materials such as brick, cement, drywall, wood, and insulation, 3D printed houses are almost made entirely out of proprietary cement. This also leads me to my next point of them being more inflation resistant. In this data list I've collected from builderonline.com, while cement and brick prices have increased by 2.8% in recent years, the price of gypsum and softwood has increased by 20.7% and 79.5% respectively. Not only that, but whereas the average home takes 7 months to build, 3D homes are usually made within 45 days. Data collected from www.canada.com shows that Canada is estimated to get around 430,000 new immigrants every year. With current house building times, it will be impossible to meet that number. Not only that, but the price of traditionally built houses might be too high for newcomers to Canada. There are more advantages, however. Not only are they cheaper, but some websites like 3dprintschooling.com believe that 3D printed houses are also a lot safer and reliable than traditional houses. Adding on to this, 3D printed houses also require less maintenance as it is easier to get replacement parts due to existing blueprints and also would therefore require lower labor costs in case maintenance is required. Finally, 3D printed houses are also very effective at maintaining temperature, which results in a more comfortable living space. I have also made a cost comparison chart. Under 3D printed homes, we can see that it requires less manpower, uses less materials, which means inflation impacts it less. They can be made according to demand. Their price increases slower due to less inflation and more accessibility. The price is usually 20 to 40% cheaper for buyers, and the material transportation cost is lower due to only really needing a 3D printer and proprietary cement. Traditional homes, on the other hand, require manpower, their building times get delayed by the weather, they take a while to produce, they need willing homeowners in order to meet demand, and their price increases alongside the cost of each of their materials. To prove my point, I've gathered some market statistics. From newhomesource.com, we found out that in upcoming years, 3D printed houses are estimated to shave 40 to 50% off of the total cost of making houses. From 3drific.com, we find out that 3D printed houses normally cost around 20 to 40% less than traditionally built houses, which is a fact that I've mentioned earlier as well. Finally, from surveys done by Realtor.com, we are informed that 66% of the respondents would consider living in a 3D printed home, while 30% believe that 3D printed homes will replace traditional means of building houses. Now, if anyone's interest has been piqued and want to know more about how they can get involved in a 3D printing job, that will be the main topic of this section. The main types of workers required in the making of a 3D printed house are 3D architects, the ones who design the blueprints, electricians, whose main job is to organize all electrical appliances and cables, plumbers, who have to deal with plumbing rather than electrical cables, and the construction workers, who are tasked with assembling the pieces of the house. The job I'll be highlighting, however, is that of a 3D architect. I believe that this is the most important job and involved job in the 3D printing industry due to them being the highest paid, highest in demand, and the ones responsible for the most important aspect of creating a 3D printed house. The first of the four main contributors to the high demand of efficient 3D architects is that, number one, a good 3D architect knows how to use materials and workers effectively. This results in an even lower overall cost for materials, such as proprietary cement and manpower. This also leads me to my next point. If a 3D architect knows what they are doing, it will result in a lower building time, as the blueprints will be completed quicker. While we're on the topic of efficient work, we might as well talk about the third reason the 3D architects are so in demand. When building homes traditionally, little mistakes can result in massive problems. Luckily, when creating digital blueprints, 3D architects have the entire internet at their fingers to double and triple check their work. This results in a far lower rate of errors. The final reason is the competitiveness of learning and succeeding in 3D architecture. Since it is a branch of engineering, students can expect to spend on average 4 years of studying to obtain a basic bachelor's degree. Considering the time it takes to be qualified in this field and how recently 3D printing homes has become a major trend, not many people are qualified to use 3D printing software or even do it effectively if they are qualified. This means that companies need to compete with each other to hire the most qualified and successful architects for their projects. But how much are they paid, you might ask? After gathering information from sites such as Glassdoors.com and Salary.com, I've compiled a spread chart of how much various companies pay 3D architects. As you can see, their salaries range from anywhere in the $70,000 per year to $170,000 per year cap. To put that into perspective, the average salary of a worker in Ontario is only $54,630. So, how can you get started? The best thing that you can possibly do is to take full advantage of our Brampton Library, and more specifically, the Makerspace program. During Makerspace times, you are able to use 3D printers, which normally cost thousands of dollars, excluding filament costs, for free. Alongside this, there is a team of friendly staff willing and able to help you if you so need. There are also additional activities that are listed, such as cutting machines, video or photo editing softwares, and button makers. This concludes my presentation. I hope that after viewing this, you have gained some knowledge related to the sensational new form of building houses that is 3D printing. It has come a long way from where it started as a desktop machine used for mainly recreational purposes and is now a revolutionary piece of technology. I also hope that anyone who has become interested in becoming a 3D architect has been inspired to use the Brampton Library's Makerspace. Thank you for listening and have a nice day.